Welcome to this Maths and Calculation module as part of the Lifting course preparation series, presented by me, Kevin Benison. Module Overview. So in this module, you'll learn about mathematical symbols, area, volume and square root, use of brackets, decimal places, simplified lifting formulas, properties in calculation of triangles, and properties in calculation of circles. So you'll need for this module a pen or pencil, notebook or some paper, a calculator with a square root function, and a copy of the SWL Training Maths tutorial for lifting. So get your stuff together and let's get started. Let's take a look at some of the symbols that you'll use on your Lift Planner Appointed Person course and indeed other lifting courses, and of course when active in those roles. So these can be found within the Maths tutorial. Firstly, let's take a look at divide. Now divide can be represented by one of two symbols. When you see either of these symbols, they simply mean divide. Then looking at greater than. Greater than simply means of higher value. So for example, 9 is greater than or of higher value than 6. And the opposite, less than. So 6 is less than or of lower value than 9. Of course then we have greater than or equal to. So the figure must be at least the same as or greater. Therefore, if we're looking at A must be greater than or equal to B, and B was to be 10, A would have to be 10 or above. So then less than or equal to, quite simply the opposite. So if A must be less than or equal to B, and B was to be 10, A would need to be 10 or below. The next symbol we'll take a look at is pi. Pi can be used in many different mathematical equations. However, we're most likely to use it in relation to circles. Now, pi is a mathematical constant, which means it has the same value all the time. It's also an irrational number, which means that it never ends. It has unlimited decimal places. However, for what we're going to be using it for, 2 decimal places is of sufficient accuracy. Therefore, the value of pi is 3.14. Let's take a look at squared, which is represented by the small 2 symbol. This means to multiply by itself. So, if you see a figure with the small 2 symbol next to it, that means you will multiply it by itself. For example, if you got 2 with the little miniature 2 symbol next to it, this means 2 squared, therefore 2 multiplied by itself, 2 times 2. And the result of this, of course, is 4. So, you may also see this 2 associated with area. So, in this case, when you have a square, which is 4 meters by 4 meters, you multiply those together, so that would be 4 meters squared, resulting in an area of 16 square meters. So be careful not to confuse meters squared with square meters. Meters squared, so 4 meters squared, would mean to multiply by itself, whereas square meters, as in 16 square meters, would represent area. So with this rectangle then, if it was 5 meters by 3.2 meters, again, multiply the two together, and that's going to give you an area of 16 square meters again. On to cubed then, which is the small 3 symbol. Well, this of course means you're multiplying the figure by itself and then again. So if we're 2 cubed, this would mean 2 times 2 times 2. So 2 times 2 is 4, and then multiply again by 2, that gives us 8. So this is commonly used with volume. So if we have a rectangle and we want to find out the volume of that rectangle, or any given shape, we'll multiply the length by the width by the height. So in this case, we have 6 meters by 3 meters by 2 meters. So 6 times 3 is 18, times 2 equals 36 cubic meters. Again, remember not to confuse your meters cubed with cubic meters. So meters cubed, if you said 3 meters cubed, that would be 3 times 3 times 3. Or if you said 36 cubic meters, that represents the volume. Another symbol that occasionally causes some confusion is square root. Now, square root is essentially the opposite of squared. So, if you take a number, when you square root that number, you are finding the number that you would multiply by itself to get your original number. So, for example, if you were to take 16 and square root 16, you would get 4, because 4 multiplied by itself gives you 16. So 4 is the square root of 16. Now, on your calculator, the square root symbol will be as shown here. So let's take a look at some examples on the calculator. The square root of 4 is 2. The square root of 16 is 4. The square root of 48 is 6.93. The square root of 55 is 7.42. And the square root of 81 is 9. Which of course means when you multiply 9 by itself, that gives you 81. Using decimal points in understanding decimal places. Decimal points are used to separate whole numbers from parts of a number. So on the left of a decimal point, you get whole numbers, which increase in value by multiples of 10 as you move to the left. So the first digit to the left will be units, then tens, then hundreds, then thousands, and so on and so forth. And numbers to the right of a decimal point are parts of a number, decreasing in value as you move to the right. So the first digit to the right of the decimal point is tenths, then hundredths, then thousandths, and so on and so forth. If we relate this to metric tons, the figure shown in the image would be 17.591 metric tons. And then to convert this to kilograms, well, there are 1,000 kilograms per metric ton. Therefore, we would just multiply this by 1,000, giving us 17,591 kilograms. So to convert from tons to kilograms, multiply by 1,000, or to convert from kilograms to tons, just divide by 1,000. When carrying out a calculation, the result may have numerous decimal places, as in a number of figures to the right of the decimal point. Therefore, what you'll likely need to do is round those off to a more suitable number of decimal places. For example, you may round off to 2 decimal places. The standard way of doing this is when you have any figure which is to the right of the decimal point and it's equal to or less than 4, you would round down. And any figure which is equal to or greater than 5, you would round up. So in this example, you have 0.591. So you have 3 decimal places. If rounding to 2 decimal places, you were rounding down, it would be 17.59. If you were rounding up, it would actually go to 17.6 tons. Now normally, with the 1, you would not round up, you would round down because it is less than 4. However, in some cases, you may need to have a result which is a minimum figure. Perhaps you're calculating the minimum working load limit for a sling. In which case, if you were to round down, as small as the difference may be, you would be slightly below the minimum by going 17.59. So it would be more helpful to round up. In this case, it would become 17.6, because rounding up from 9 would be a 0, which would take the 5 up to a 6. So you would have 17.6 tons. So rounding down to 2 decimal places in this case, which would be the normal way because you have a 1, it would be 17.59, or rounding up, it would be 17.6. There's further explanation on the use of decimal points and understanding decimal places, and a couple of example calculations that you can do in our downloadable maths tutorial. Using brackets. Brackets are used to separate calculations. This is because if the calculation is not separated correctly, it could result in an incorrect answer or a different answer. So, looking at an example, what is the result of this calculation? You've got 17 plus 5 multiplied by 8. Well, depending on the sequence that you do that calculation, it could result in either 176 or 57, depending on how you break the calculation up. So if we use brackets to look at the two options, firstly, if we were to do 17 plus 5, which equals 22, then multiply that by 8, that would give us an answer of 176. Or, if we were to put the brackets around the 5 multiplied by 8, then we would do, of course, 5 multiplied by 8, which is 40, and add on 17, resulting in 57. Now, there are mathematical rules on what to do first. So if you didn't have any brackets, this would actually be the correct way of doing it, because multiply or divide will always come before add or subtract. However, you may wish to do the 17 plus 5 before you multiply by 8. So then you would have to use the brackets accordingly. The brackets can be helpful where you have a sequenced calculation within your lifting calculations. Further examples of this and ones that you can try are in the downloadable maths tutorial. Multiply and divide triangles. These provide us with a simple way of remembering a formula for many calculations which require multiplication and/or division. For example, they're used in things like Ohm's law and time, speed and distance calculations. So we have a triangle which has 3 sections. Each of these sections will represent a figure or a part of the calculation. Now, the top figure of the 3 is always divided by either one of the bottom 2, whichever one you have. So out of the triangle, you need to start with 2 pieces of information, then you can use it to calculate the third. In this case, A would be divided by either B or C, depending on which one you had. If you have B and C and you want to find A, you would multiply those together. So for example, A divided by B equals C, A divided by C equals B, or B multiplied by C equals A. So let's take a look at a simple example. Well, we have 12 in the top and 6 in one of the bottom sections. So we'll have two figures available, and we need to find the third. 12 divided by 6 then gives us, of course, 2. Going the other way, 12 divided by 2 equals 6, or 6 multiplied by 2 equals 12. Now, there are many ways that these triangles can be used within lifting operations calculations. So let's take a look at some examples. For calculation of the rating of slings, or indeed the safe working load of a configuration, we can use it for uniform load method. You'll get more details of how to use uniform load method either when you attend your course or in the online training platform. Just a brief overview then. In the top section, in this case, you'll have the load weight. In the bottom, you'll have mode factor. And then in the other bottom section, you have working load limit of the individual accessory. So, to find out the maximum load weight for a configuration, you would find your mode factor through uniform load method, multiply that by the working load limit of the individual leg to give you the maximum load weight. If you wanted to find out the minimum working load limit per leg, you would do load weight divided by the relevant mode factor to give you the individual working load limit as a minimum. You can refer to our lifting operations pocket assistant to find an overview of the mode factors that would be used for uniform load method calculations. You'll get further explanation of how to do this when you attend your course and within the online training platform. Another way we can use the triangle is for MAC calculations. So you need to get the maximum point load for the crane, which of course is the outrigger load or the track load. Divide that by the maximum permissible ground bearing pressure. So what is the maximum weight you're allowed to apply to the ground in tons per square metre? When you divide the maximum point load by the ground bearing pressure, you'll then get the minimum mat area required in square metres. Or the other way, maximum point load divided by mat area equals then the resulting ground bearing pressure. You'll get more information on this when you attend your course or in the online training platform. And another example of how to use the triangles is with percentages. So if you have A and C, then in the other section, you'll have your percentage as a decimal value. So for example, 85% would equal 0.85. So if you wanted to find what percentage A is of C, you would do A divided by C. That will tell you the percentage as a decimal value. So let's take a look at some examples. If you have 60 up the top and 82 in one of the bottom sections, and you want to find what percentage 60 is of 82, you would do 60 divided by 82, which then would give you 0.73 or 73%. Therefore, that means that 60 is 73% of 82. This can be useful in terms of load weight and rated capacity. So if you were lifting 60 tons and you had a rated capacity on your crane of 82 tons, you wanted to find out what percentage of capacity you were using, your utilisation, 60 divided by 82, giving you 73% utilisation. Looking at another example, if you have 55 and you want to find out what 55 is 85% of, so any percentage, whatever percentage you wanted to use, then you would do 55 divided by 0.85, then giving you 64.7 tonnes. Again, this may be useful if you know what your gross load weight is and you know what maximum percentage of capacity you want to work at. Then you can do the 55 tonnes, or your load weight, divided by the percentage to find out what your minimum rated capacity needs to be. So in this case again, if you're lifting 55 tonnes and you want to ensure that you're working at no greater than 85% utilisation, 55 divided by 0.85 equals a minimum rated capacity of 64.7 tonnes. And another example, if you wanted to find out the value of a given percentage of a figure, so in this case we're using the example of 65% of 42, then you can do your percentage as a decimal value times that figure, so in this case 0.65 times 42, which will then give you 27.3, which would mean if you had a rated capacity on the crane of 42 tonnes and you wanted to stay within 65%, you would do 0.65 times 42, giving you a maximum gross load weight of 27.3 tonnes. You'll learn more about this when you attend your course, or indeed in the online training platform. Triangles. It's helpful to understand the properties and principles of triangles, as triangles appear in many elements of lifting. So of course, triangles always have three sides and will have three angles. Now, when you add the three angles together, this will always equal 180 degrees. If you have one of the angles that's 90 degrees, that's known as a right angle. There are three types of triangle, and this is based on how many sides there are of the triangle which are of equal length. So if you have all three sides which are of different lengths, therefore there's only one side of equal length, this is a scalene triangle. Where there are two sides of equal length, this is an isosceles triangle. And where all three sides are of equal length, this is an equilateral triangle. So of course in an equilateral triangle where all three sides are of equal length, all the angles will be the same too. So each of the angles will be 60 degrees. Now in terms of the sides of a triangle, so the longest side of a triangle is always called the hypotenuse. The other two sides are called the adjacent and the opposite sides. But which is which actually depends on what angle you're referring to. So in the UK and Europe, with regards to lifting, we're usually referring to the top angle. So of course, the adjacent side, adjacent meaning next to, would be next to the angle. And then you would have the opposite side. Of course, if you're referring to the other angle in the triangle, then those sides would switch around. So the adjacent next to the angle, and then the opposite side opposite the angle. With regards to lifting, you can see in this example of a simple slinging method where our triangle would fit into that. Split the slinging method down the middle, and you now have a right-angled triangle. So it's helpful for us to understand how to calculate the length of sides of the triangle, because this can help us in a number of situations, particularly with regards to calculating sling length. So to do this, we use what's called Pythagoras' theorem. Pythagoras' theorem is actually a very simple method of calculating the length of sides of a triangle for a right-angled triangle. So you must have a right angle within the triangle, and of course you do that in a slinging method by splitting it down the middle. For the purposes of this, we're just going to call the sides of the triangle A, B and C. The principle of this method is that when you create a square area on each of the two shorter sides of the triangle, as in you multiply the length of each of the two shorter sides by themselves, so A multiplied by A to create a square area, and B multiplied by B to create a square area. When you add the area of those two sides together, that would equal the square area created by the longest side, the hypotenuse. So the area created by A and B would fit equally into the area created by C. Hence, A squared plus B squared equals C squared. Or more simply, A times A plus B times B equals C times C. So let's take a look at an example of that. If we have 3 metre length on the bottom side and 4.5 metre length on this side, we can use those to calculate the length of the hypotenuse. So of course, using our formula, we would do 3 times 3, and then we would add on 4.5 times 4.5. Notice the use of brackets here. So that gives us 9 plus 20.25, and the result of that is 29.25. So this represents the square area that would be created by the hypotenuse. So remembering back to when we were talking about squared and square root, if we want to get back down to the dimension, we'll need to square root this figure, which of course is this button on our calculator. So the result of that then, square root of 29.25, is 5.4 metres. And that is the length of the hypotenuse in this case. Looking at how else this may apply, if you have a load which is a 4-point lift, so we're looking in plan view and we have a lifting point on each corner, something that is often overlooked is that the greatest distance between those connection points is not along the length of the load or across the width, but actually between diagonally opposite lifting points. So we need to calculate this. By splitting the load like that, we have now created two right-angled triangles. So we can apply Pythagoras' theorem to work out that diagonal distance, i.e. the hypotenuse of those triangles. Let's consider then we've got 7 metre length and 2.5 metre width. So, of course, 7 times 7 plus 2.5 times 2.5. That gives us 49 plus 6.25. And the result of that being 55.25. So we've now got the square area created by the hypotenuse. And then to get back down to the dimension of the hypotenuse, we'll need to square root 55.25, resulting in a hypotenuse length of 7.43 metres. There's more information and further examples of this within the downloadable maths tutorial, and you can learn more about how to apply this to slinging both in your course and in the online training platform. Circles. Again, understanding the properties and principles of circles can be very helpful in many elements of lifting. So just looking at the basics. The measurement from one side of a circle to the other is called the diameter. Half of that distance is called the radius. And then the measurement all the way around the circle is called the circumference. To calculate the circumference of a circle, we first need to know the diameter. What we do then is we multiply the diameter by pi. And as we mentioned earlier, pi is an irrational number, meaning it has unlimited decimal places, but we're just going to stick to 2 which is of sufficient accuracy for what we are doing. So 3.14 times diameter gives us circumference. If we wish to calculate the area of a circle, it's 3.14 pi multiplied by radius squared, hence pi r squared. So that's pi times radius, and that gives us area. Let's take a look at an example then. If we have a diameter of 6 metres and we want to calculate the circumference, well, of course, that would give us a radius of 3 metres in this case. So pi 3.14 times the diameter, 6, gives us 18.84 metres. That's a circumference of 18.84. Understanding that can be useful in terms of sling length for cylindrical loads, depending on how you're slinging the load. You'll learn more about that when you attend your course and in the online training platform. Calculating the area of a circle. So pi times radius squared equals area. So in this case, we've got a diameter of 6 metres, therefore a radius of 3 metres, pi 3.14 times 3 squared, 3 times 3, which of course is 9, gives us an area of 28.26 square metres. The area of that circle, 28.26 square metres. Thanks very much for joining us on this module. We'll look forward to seeing you on another module soon, on one of our lifting operations courses, and as a member of our online learning platform.